Welcome to the video lecture series on theory of computation, and in today's video lecture we'll be discussing about the way of converting NFA with epsilon to DFA, and finally an NFA diagram will be given and you are supposed to convert that to a DFA, and this is a very important problem. So we will just go through the procedure first. So what is the first procedure to convert an NFA to DFA? And NFA with epsilon can be converted as the first step. We have to find the epsilon closure for the initial state and name that set as a new state. I actually emphasize that it is going to be a set. Okay, you might be getting only one state, or you might be getting more than one state in that case. So obviously that is called as a set. So the set has to be given a new name for this. In this case, we will just name it as A here. Now, after getting a new name, you apply all the input symbols which is pertinent to NFA to the new set. Okay, that is delta dash A comma capital A comma small a, where small a is actually considered as all the input symbols. Okay, and finally that delta dash A is equivalent to epsilon closure, and inside epsilon closure you have to find the transition state of when a particular input is applied on A, so what it has to do. Okay, and as a result, if a new state is getting generated, again you have to repeat the process. That means all the input symbols has to be applied on new state again. Okay, and this process has to be continued unless and until no new states is getting generated. So that is the idea behind this NFA. To NFA to DFA conversion. So let us have a discussion on a problem here. So I have a problem here. So we are having Q1 to Q2, so 6 states together. Okay, and you have respective transitions as epsilon here, and epsilon here. Okay, so now the first thing is we have to find the epsilon closure for initial state. So in this diagram, the initial state is actually Q1. So I just find epsilon closure of Q1. Okay, when you find epsilon closure of Q1, you can see here the epsilon, when you apply epsilon Q1 to Q2, actually it goes to Q2, it goes to Q4, and when epsilon is applied in Q1, it also goes to Q6. Okay, and from Q6 it's again going to Q1 and Q2, so Q1 and Q2 is already covered. So the answer is epsilon closure of Q1, you will get Q1 itself, then it goes to Q2, it goes to Q4, then it goes to Q6. Okay, so name this new state as A here. Okay, so I have named this as A. Now the next step we are supposed to do is we have to apply all the input symbols. So what are the input symbols? What are the input symbols in this case? The input symbols is A and B. Except epsilon, rest of the things are called as input symbols here. So A and B is called as input symbols. So I want to find the delta dash of capital A, and I apply A here. First input symbol I apply A here. Okay, so what is equal to delta dash? Delta dash is equal to epsilon closure delta of capital A, and I apply an input symbol called as small a here. Okay, now you see here what is actually A here. So what is A? So epsilon closure delta, and A is equivalent to Q1, Q2, Q4, Q6, and I apply A here. Okay, so in short, this can be named as, you have to see here, so epsilon closure, so you have to use delta 1 of Q1 comma A, union of delta of Q2 comma A, and union of delta of Q4 comma A, and union of delta of Q6 comma A. So in this case Q6 comma A. So this is the idea behind this. So every time you have to put union here. Okay, now see here in this 4 states, actually I cannot apply in Q1, I cannot apply A, and obviously that is going to be pi here. So here I use epsilon closure So epsilon closure, the first answer is pi because I cannot apply on Q1, and when I apply Q2, A in Q2, so in Q2 if I apply A, it goes to Q3, isn't it? So it goes to Q3, so I get Q3, so union of Q3, and next is union, so I cannot apply Q4 on A cannot be applied in Q4, so again pi, and you cannot apply A on Q6 also, so that is also pi. Okay, so the only possibility is actually Q3, so we have to find epsilon closure of Q3. So epsilon closure of Q3. Okay, now when you take epsilon closure of Q3, what is epsilon closure of Q3? So in Q3 to Q6 there is a transition, Q6 to Q1 there is a transition, Q1 to Q2 is a transition, and Q4 is a transition. So you will get the answer called as epsilon closure of Q3 is equivalent to Q1, Q2, Q4, Q3 and Q6. Okay, so these are the sets. Okay, I just put it in an order. So Q1, Q2, Q3, Q4 and Q6. Okay, so check it out whether this is equivalent to the previous state called as A. In previous state you have 4 states here in A, Q1, Q2, Q4 and Q6, but here you have 5 states, so definitely it is different from that. So name this state as B here. So name this state as B. Okay, so this is the idea behind this. Now for a new state called as A, you have applied input A called as A here, but what is the next input? The next input is B. Okay, so now you find delta dash of A comma B here. So it is equivalent to epsilon closure of delta of A comma B. Okay, so this is also equivalent to epsilon closure, and delta of in A can be written as Q1, Q2, Q4 and Q6, and you can just apply B here. Okay, so now see here in these 4 states where B can be applied. You cannot apply B on Q1. Okay, Q2 cannot be applied, but in Q4 you can apply B, but Q6 you cannot apply. Okay, when actually you apply in Q4, you will be getting the answer called as Q5. So rest of the things are pi here. So epsilon closure. Okay, so only one possibility is there, that is delta of Q4 comma B. So only in this state you can apply. If you apply it is Q4, so you will get epsilon closure of Q5. Okay, so now see what is epsilon closure of Q5. So when you see epsilon closure of Q5, you can see that in Q5, Q6, then you go to Q1, then you go to Q2 and Q4. Okay, so the answer is Q1, Q2, Q4, Q5 and Q6. That is the answer. So Q1, Q2, Q4, Q5 and Q6. Okay, now check it out whether this state is actually a new state. Q1, Q2, Q3 is there, but here I don't have any Q3, so obviously this is a new state. So just check it out with the states in A. In A actually I got Q1, Q2, Q3, Q1, Q2, Q4 and Q6. But here I have got Q1, Q2, Q4, Q5 and Q6. Okay, so Q5 does not exist in A. And in B also Q5 does not exist. So obviously this is called as a new state here. So new state, you can name this as C here. Okay, so what the algorithm says, procedure says, unless and until you get a new state, you should repeat the process by applying all the input symbols. Okay, that means what is all the input symbols? In this case, all the input symbols are actually A and B. Okay, so I have applied A and B on the set called as A. Now I have to apply input symbols A and B on both the sets B and C. Now we'll do that. I just keep it here. Okay. Now we'll just take the apply the input here. So I use delta dash b comma a here. So it is equivalent to epsilon closure delta of b comma a. Okay. So what is epsilon closure of b comma a? So epsilon closure of b comma a, and see what is there for b. Okay, set b is actually having here q1, q2, q3, q4 and q6. Okay, q1, q2, q3, q4 and q6. Okay, just I apply here set b. So q1, q2, q3, q4 and q6. Okay, and I have to apply a here. Now out of this states where I can apply a, okay, the only possibility is a can be applied in the diagram, that in only q2 a can be applied. Okay, so rest of the things I cannot apply here. So only q2, so rest of the states I cannot apply a. So epsilon closure of delta of q2 comma a. Okay, if I apply q2 comma a, where it goes to q3. So epsilon closure of q3. Okay, if actually I have q3, so this is actually q3. If I apply q3, so epsilon closure of q3, already there is a diagram here. Epsilon closure of q3, you get answer called as b here. So see here, epsilon closure of q3 is actually you are getting b. Okay, so definitely you would get the same answer here. So so state is actually not repeating here. So epsilon closure of q3 is b here. Okay, now delta dash of b comma b. Now apply the second input. So epsilon closure. So what is b here? I can apply delta of q1 comma q2 comma q3 comma q4 comma q6 comma b. Okay, so out of these states, in which states I can apply b? Okay, the only possibility is b can be applied only in q4. Okay, so b, you can see that b can be only applied in q4 here. So rest of the states I cannot apply b. So when I apply in b in q4, where it goes? It goes to q5, isn't it? So I use epsilon closure delta of q4 comma b. Okay, so I now just close epsilon closure delta, sorry, it is actually q5. Okay, epsilon closure of q5. When I just go to epsilon closure of q5, so whether there is any transition for epsilon closure of q5, just go to the previous state. Yes, you have here. Okay, so epsilon closure of q5, it is actually generating c here. You are generating the state called as c. So in this case also I just have c here. Okay, now I am not generating anything. It is actually already generated state is again generating now. But what happens is I have two new states. One is called as b. For input state set called as b, I have applied both the inputs. But for c, still inputs has to be applied. So how to apply that? So delta dash of capital C comma a is equal to epsilon closure. Okay, and what is C here? So C is actually Q1, Q2, Q4 and Q6, isn't it? So C is actually Q1, Q2, Q4, Q5 and Q6. Okay, so just Q1, Q2, Q4, Q5 and Q6. So I just apply B here. Now in the states actually where I can apply B. Okay, so I can apply B only in Q4. Okay, if I apply B in Q4, you can see the diagram. Only in Q4 I can apply B, so it goes to Q5. So other states I cannot apply. So use epsilon closure. So delta of Q4, okay, I think it is C comma A, isn't it? Okay, small mistake here. So it is actually A, first A. Okay. Now where I can apply A here? In A actually I can apply in Q2, isn't it? It goes to Q3. So I just use Q2 comma A. So Q2 comma A again goes to Q3. So epsilon closure of Q3. Okay. So epsilon closure of Q3, what is the answer? So you are already getting the same answer. Epsilon closure of Q3, you will get the answer called as B. Okay. Epsilon closure of B here. Now one input I have applied. So no new state is getting generated so far except B and C. Now I apply delta dash of C comma B. So epsilon closure Q1 comma Q2 comma Q4 comma Q5 and Q6 comma B. Okay, so where I can apply this B here? So I can apply only in Q4. When I apply in Q4, you can see the diagram. So in Q4 I can apply B, it goes to Q6. So when I apply in Q4, it goes to Q5. So rest of the states I cannot apply. So epsilon closure delta of Q4 comma B. Okay, so Q4 it goes to Q5. So epsilon closure of Q5. Okay, so you know that epsilon closure of Q5 is already generating C here. So this case it is actually generating C, same output you are getting. Okay, so no new states is applied. So two new states has been generated. One is B and C. Three new states A, B, C, and when I apply inputs on A, B, C, it is not further generating any kind of new input states. So the procedure comes to an halt over here. So we have to stop the procedure. Now we have to just construct the diagram, transition table. So the transition table is transition table, I have three new states. One is A, another is B, and another is C here. And the input states, input symbols are A and B. Okay. Now, if I apply input A on set A, actually what I generate? Actually, I generate B. Okay. If I apply input B on a set called as A, now I generate C. Okay. Now come here. If I input B, if I apply A on set B, what is generated? So if I apply A on set B, actually I am generating B here. It is generating B. Okay. So I just write B, and if I apply input B on set B, what it generates? So if I apply input B on set B, it is generating C here. It is generating C. So I just write C here. Okay. So now for input set C, an input symbol is A. Now when A is applied on C, what happens? So when A is applied on C, it actually generates B here. So B. Okay. Now when input B is applied on C, okay, what it is generating? So when input B is applied on C, it is actually generating C here. Okay, so I write C. Now the next issue is, so we have to identify which is the initial state and final state in this case. Okay, how will you identify the initial state and final state in this case? It's a very simple process. See here, the original diagram. In original diagram, so Q1 is called as an initial state and Q6 is called as final state. Okay, now which is actually having the initial state here? So all are having initial states in this case. Okay, Q1 is having initial state. So we will just name A as initial state. Okay, we will name A as initial state here. So A is going to be the initial state, And now the next question is, which is final state? So wherever Q6 exists, Q6 is called as a final state. In which state, in which set actually Q6 exists? So Q6 exists in A, Q6 also exists in B, and Q6 also exists in C also. Okay, that means wherever Q6 is existing, then all the states are called as final state. So it means in this case everything is called as a final state. So I put a star here, I put a star here, and I put a star here. Okay, all these are called as final states. Now we have to construct a diagram, DFA diagram. So you just use capital A, capital B, and capital C. Okay, since all are final state, I just put a round here and I make A as initial state. Okay, because that is going to be the first state, I make A as initial state. Now when A is applied on set A, okay, it goes to B. So when A is applied on set A, it goes to B. When B is applied on set A, it goes to C. Okay, when A is applied on B, it comes to B itself. Okay, when B is applied on capital B, okay, so it goes to C. So it goes to C. Okay, now in C, if A is applied, where it goes? In C, if A is applied, it goes to B. Okay, and when C, if we apply B, where it goes? It goes to C itself. So that's it. Okay, so this diagram is called as NFA diagram. Okay, DFA diagram. Okay, so that's about NFA and DFA. Thanks for watching a video. Have a good day.